Hey, welcome to 376. In this video, I'm going to talk about how to solder your circuit board. So everybody in this class should have a lab kit. This lab kit is $65, cash or check, written out to Society of Women Engineers. It makes the class a whole lot more fun. So kind of think about it as a textbook that you actually use. When you open up the lab kit, it's got all sorts of fun components to play with. The main one we want to look at is your printed circuit board, your PCB. This video, we're going to look at how to take this PCB, solder it together, and wind up with something that looks like this. Now, your color might be green or blue. Color doesn't really matter, just kind of decorative. What the board has is, this is the bare board. It's got the PIC microcontroller, LEDs, some connectors. This is the FTDI chip that lets you connect to your PC using the serial port and LCD display. It just plugs in on the top. I'm going to look at how to solder this board. If you're wondering where to find this video, it's under Bison Academy. Bison Academy, the semi-official website for the Electrical Computer Engineering Department, under 376. So here's the course. If you go under Lab Kits, here's what's inside the lab kit. You want to wind up with a circuit board that looks like this. There's a video of how to build it. What's inside the box, a bunch of components. When you're done, here's what the board should look like. And here's the parts that are inside the kit. So the PCB comes from a jail PCB. PIC microcontroller, FTDI, LCD, those actually get soldered onto the board. There's external components as well. You have a keypad, H-bridge, range sensor, temperature sensor, light sensor, 3-color LED, NeoPixel RGB LEDs, stepper motors, speakers, wiring kit, miscellaneous parts. Those are all things that we'll be using throughout the semester as we go through various topics. So let's start with soldering your board. I like to say soldering is tedious. It's not hard. You just have to be patient. It takes about 2 hours to solder your board. Now, one of the first things you need are safety glasses. I wear safety glasses normally. If not, we have safety glasses. If you need safety glasses, just let me know and we'll get you some. And they're not expensive. It's an OSHA violation to solder without using safety glasses. Also, we don't want you to hurt yourself. Now, to get started, you're going to need a soldering iron, some solder, and a good pair of tweezers. The solder that I'm using is 6040 solder. It's a tin lead solder, not legal in Europe, legal in the US. Lead solder flows better, sticks better, works a whole lot better than lead-free solder. You can get lead-free solder as well. If you use leaded solder like I'm doing, set the temperature of the soldering iron to about 700 degrees. Jeff likes 650, I like 700. It's got to be hot enough to melt the solder. What that means is, at 700, don't leave the soldering iron on the board too long, like more than 30 seconds. If it gets too hot, that's going to melt the pads, and the pads lift off. So here's the different components in the pads. I'm going to start with the surface mount parts, these parts right here. They look kind of intimidating, but surface mount really isn't all that bad. What I like doing is start by putting a dab of solder on just one of the two pads. So I'm right-handed, so I'm going to turn the circuit board sideways and just add solder to one of those pads, kind of like so. You can see there's a little bead of solder. On one side. Okay, once I get those little beads of solder on there, I am then going to put on the LEDs. So for this, the LEDs are kind of small, easily fall on the floor. So take something like a Gatorade cap, makes a nice little container for the LEDs. I'm going to start peeling them out and dump them inside that cap. It can be a challenge. There it goes. Just dumping the LEDs in there. Now if you look at the LEDs, these are actually polarized. There's a top side and a bottom side. You can kind of see this one has an arrow. That's a diode. That's the direction of current flow. That's the bottom side. When you flip it over, there's a little window. That window's the top side, and there's a green dot. That green dot is ground. Ground is the bottom side of the board over here. I want the green dot facing left. So what I do is I take the LEDs, tap them until one's facing up, facing left, like this puppy. Grab them. Take the soldering iron, melt the solder, get it lined up. First one's on. Grab another LED. See, this one's facing left. Melt the solder, get it lined up, take it away. Okay, those are on the board. Once I get one side soldered, solder the other side. So melt the soldering iron to the base. Try to melt the pad, reheat the pad in the part. Like so. I've got two LEDs on the board. Now this isn't necessary, but we want to check it out. Here I took a 9-volt battery and soldered a 1K resistor on the plus side. Minus side is tied to ground. If you apply plus over here, minus on the left, the first pin is just ground. Nothing happens. The second pin is the first LED, third pin, fourth pin, fifth pin. You can check out your LEDs that way. If one of the LEDs is in backwards, you can remove it by going back and forth. I don't want to push on it. That'll lift off the pad. You just kind of heat the soldering iron on both sides, and eventually the LED just slides right off. Once you get the LED off, you can try to fix it, or LEDs are cheap. Just grab a new one. Make sure you got the polarity right. Green dot facing left. I lost it. There it is. Get it lined up. We start at the back side, and you can test it. The first pin over here is ground. The second pin is the first LED in. There the LED is working. Okay, so that checks out the LEDs. Once you get the LEDs on the board all the way across, start soldering in the components. What you do next doesn't really matter. Everything on the board gets filled in. I'm going to do these arrays next. So these are the resistor arrays. They should both be 10 pins across. Occasionally, some of the kits have a 9-pin device. This one works just as well. 10 pins avoids confusion. There's the 100K and 10K. Got to get these right. These are really hard to desolder if you get them in wrong. The 100K is 104. So you look for the notation. This is a 103. That's a 10K. 10K goes down here. 104 is 10 times 10 to the fourth. That's the 100K. 100K goes on the top. Don't go by the color. Color is decorative. Depends upon which batch we bought, what year it is. They could be any color, but you wanted the numbers. 104, 100K, 103, 10K. Now, if you have one that's only 9 pins across, it is left justified. That one right there is the ground. I want ground to go over here on the left. If it's 10 pins across, doesn't matter. Put it in either way. For 9 pins, polarity does matter. To get these in the board, this is where you need 3 hands. So you put the component in the board, that's one hand. Hold the part with your second hand. Hold the soldering iron with your third hand. Hold the solder with a fourth hand. And just solder one pin. So Get the solder on the pad and the pin, melt it, and there it's on the board. Oops, got the wrong one. There it is. But invariably, it's going to be cockeyed. If it's cockeyed, just remelt it, push it down flat. With one pin, I can melt it and adjust whether it's flat or not. Once two pins are soldered, you're kind of out of luck. For this one, again, I put the soldering in before I put the part in. One pin's not a problem. I'll just remelt that one pin. It should pop right in. Get it adjusted. There it's in there. And that's kind of what it looks like. Again, don't go by the color. Go by 104, 100K, 103, 10K. Once you get that in there on the board, I solder the rest of the pins. So here, there's kind of a beat to it. I just hold it on for like 3 seconds. Solder should flow right on. And what I want is kind of a little volcano. I want the solder to stick the pin and the pad both at the same time. With the leaded solder flows really nicely. If you have the lead-free solder just, it doesn't flow, doesn't melt very well. It's brittle. A lot of things I don't like about lead-free solder. But if you're in Europe, leaded solder is not legal. And there you have these components on the board. Kind of do the same. There's the rest of the components going around the board. They all fit just kind of one way. Let's do the resistors next. For the resistors, this one is 100 ohm. That's brown, black, brown. Everybody else is 1K. Brown, black, red. I like doing for the resistors. So these are 1K resistors. Brown, black, red. I'm going to take the resistors, bend them so they fit in the board. And resistors are not polarized. Direction doesn't matter. I'm going to have the gold facing left for all of them. That's just my personal choice. Again, resistors are not polarized. Direction doesn't matter. Kind of get them in the board like so. I'll just do 3 of them. Get them in the board flat. Flip the board over. And then I can take these wires and kind of bend them out. That keeps the part from falling out. I can now solder those wires onto the board. So solder the first pin, second, third, Once you get those soldered in, use a wire cutter to clip off the leads. Just cut off the leads right by the board. And voila, that's kind of what it looks like. Next, let's put in the, repeat for all the rest of the LEDs. Next, let's put in the push buttons. The push buttons only fit in the board one way. So they've got the connections on the left side, right side that goes this way. Just kind of put them over the part. Try to get all 4 pins lined up. Just push right in. First push button's in. Second one, get them in the holes, push it down. Second one's in, on down the line. Flip it over. Now we want to solder those pins. We'll touch the pad and the pin, melt on the solder. Actually, I have all the pins inserted at the same time. That prevents mistake of soldering an empty hole, which is going to make adding the part a little bit harder. So we've got 4 push buttons in, like so. Okay, fast forward a little bit. I've got the resistors soldered in the board. I've got the resistor arrays soldered, the LED soldered, push button soldered. Now let's add the PIC chip. So this is the PIC microcontroller. It's in a socket. Leave the chip in the socket. What the socket does is if you burn out the processor, you can replace it without having to basically build a new board. Costs an extra 20-30 cents per socket. It makes life a whole lot easier. If your PIC chip dies, they do die. Not often, but that does happen. The challenge is trying to get all these pins in the hole at the same time. So there I managed to get it in. Otherwise, might have to take a small screwdriver or tweezers, try to bend the pins to get them in the holes. And again, this is where you need 3 hands. One hand to hold the parts, the PIC chip on the board. Second hand to hold the solder. Third hand to hold the soldering iron. And just solder a single pin. The reason for single pin is usually, like here, the part is cockeyed. When a single pin is soldered, I can remelt the solder, push the processor down so it's flat against the board. Now it's on there flat. Once it's on there flat, you can solder a couple more pins. I'm just going to do one more right now. Solder the rest of the end. Once 2 pins are soldered, it's not moving. Okay, next, let's do the 16x1 header. Goes up here. That connects to the LCD display. Again, you use 3 hands. One holds the part in the board. The second hand holds the solder. Like so. Third hand holds the soldering iron. And just solder a single pin. Again, flip it over, make sure it's straight. And that one actually got on pretty good. Once it's straight, you can solder a second pin. That locks it in place. Okay, now the 6-pin headers. There's 2 on the bottom and 2 over here. The 6-pin headers, this is just a convenient source of power, ground, and it connects the FTDI chip. Okay, now that we have the 6-pin headers connected, the 16-pin header connected, add the potentiometer. This just goes right through the board, pops through the 5 holes, snaps in. The little 5K pot is typically a little blue one, kind of like this. Goes in these 3 holes. Finally, the last thing to add are these little 2-pin connectors. With the 2-pin connectors, take the long strip, connect these little headers to the end, put it in there, and snap off 2 pins at a time. So there's one set of 2 pins. I've got 3 pins there. I'll cut that down to 2. Another set of 2 pins. You should have 5 of these. Number 3, 4, and 5. These go right here. And what you do is you stick them in the slot. Use your 3 hands to flip it over. Hold the solder. Hold the soldering iron. Hold the pin. Hold the board. Get it tacked on. And usually it's cockeyed. That was actually pretty good. Repeat for the other ones. At this point, all the components are on your board. You can flip it over and start soldering all the pins that aren't connected. So here, just flipped over the board. I'm soldering the pins one by one. all the pins on the board. Time passes, and I wind up with all the bottom side soldered. Kind of a sidelight. About halfway through the semester, about a third of the boards have quit working. Typically the cause is just a bad solder connection. It eventually oxidizes, opens up. The way I fix it is you just remelt the solder connections, kind of like so. Just hold on about 3 seconds, let the solder remelt. Do that for all the pins on your board. That will usually fix it. It takes about 5 minutes. Quick, easy way to do it. You could spend hours trying to debug it, figure out which pin it is, or there just aren't that many pins on the board. It's got to be one of them. Finally, the last thing would be add the LCD display and the FTDI chip. So snap off 16 pins. There goes the LCD. 6 pins here. And 6 pins here. Okay, 7. Next, let's add the FTDI chip. That comes in this little bag. Open it up. Here's the FTDI chip. That is bottom justified, kind of like so. The bottom pin goes over here on the left. There's extra pins that we're not using. We just don't solder those. Try to get that down flat on the board so that this pin is the bottom pin on the connection. Solder in the FTDI. We'll just do 2 pins for now. Pause the video a bit later to get the rest of them in. Finally, let's add the LCD display. So here's what the LCD looks like. It fits on these 16 pins right here. Kind of get it to lie down flat, and then solder all 16 pins. Finally, the last thing, once your board's all soldered together like so, is add the rubber feet to the bottom that keeps your board from shorting out if you put it on a metal surface, and makes it lie flatter. Now the rubber feet in your lab kit varies. It's whichever ones I could find on sale that year. At that point, your board's complete. If you plug it into your computer, really shouldn't see anything quite yet. You need to download a program to have it do anything. That'll be the next video, how to download a program. What you can do is adjust this guy right here. That's the contrast on the display. It should go from all black to clear. You want something in the middle. Apparently there is a program on this chip that's running. Yours is probably blank. But go to the next video to see how to download a program.